All right, so next up is David from ARIN. He's going to talk about DNS best practices, I guess. Online or remote? Oh, in person? Remote? All right. Thank you.
Can you hear me okay in the room?
Yes, sir.
All right. Good morning. I'll try to go a little bit faster since it seems like we're running short on time. I say good morning. I guess good afternoon to the rest of you in the different time zones. So I want to talk about DNS services at ARIN and DNSSEC practices that we have. I'm an SRE at ARIN. I've been with the company for a little over 8.5 years. My main responsibilities lie with the DNS infrastructure and maintaining our provisioning database. ARIN's an RIR. Most of you in the room probably know this, but just for those who don't, we administer internet number resources for Canada, United States, and many Caribbean and North Atlantic islands. As part of that responsibility, we provide supporting services for things like routing security frameworks like RPKI, RR.
Sorry, David, can you just speak up a little louder? People are having a hard time hearing.
Absolutely. Let me see if I can move my mic. Is this a little bit clearer?
If you can go a little bit louder, it'd be great.
Sure, one moment. Let's see. How's this?
That sounds better.
Okay. All right, I won't go back because that's mostly just summary stuff, but so one of the big services that we run at ARIN is DNS. So that's what I plan on going over today. The DNS service we run can largely fit into 3 sort of buckets. The first is reverse DNS, where responses to DNS lookups against IP addresses, mainly PTRs, are served, zones like 8 and out of ARPA. The second we generally refer to as corporate DNS. That's things like the ARIN.net zone and the reverses like 136, 136, 192 and out of ARPA. We maintain internal and external views of our corporate DNS, with the internal view differences largely being things like components to VIPs that are externally exposed, things like that. Finally, we maintain secondary DNS for a few organizations, things like the other RIRs. The zones listed here are from RIPE, AFRINIC, LACNIC, and APNIC respectively. In addition to the RIRs, some of the supporting organizations in the RIR ecosystem, like the NRO and the ICANN ASO, use these secondary services. And on a separate set of instances, we run the A component of in-network servers to ARPA. Diving a bit deeper into reverse DNS, the general procedure that zones go through to be served starts with the provisioning system that we call ZoneGen, that then goes to a DNSSEC signing step before being distributed by our hidden distribution masters, which send the zones to our public-facing services sites, or what we call PFS, and the distribution masters that also send the zones to a number of secondary providers, including VeriSign. I think I saw Dwayne Wessels in the room earlier. Looking closer at ZoneGen, that data is compiled into zones from 2 sources. One is the provisioning database, which we refer to as John Pastell's notebook, or JPN, and the second being zonelets from other RIRs. Those zonelets are DNS zone data bits from zones where another RIR might be a minority holder of the zone and ARIN is the majority holder. So that data is compiled with information from our database and produced into zones and then sent to the DNSSEC signing step. ZoneGen runs double duty and also takes the signed zones from our distribution master and generates zonelets for the other RIRs where we might be the minority holder and the other RIRs are the majority holder. The next step reverse DNS goes through is DNSSEC signing, which at ARIN is a bump in the wire signing through a hardware appliance made by Security64, which is called the DNS Signer. This appliance also performs all of the ZSK rollovers for us monthly and initiates the KSK roles and has some safety mechanisms built around that. That second bucket that I mentioned, corporate DNS, follows a pretty similar path, but the biggest difference is that the provisioning step is largely through version control, namely Git, and some scripting and some other hidden distribution masters, and uses a separate set of services or servers in PFS. And that last bucket, secondary DNS, is generally just very standard primary and secondary syncing. We go through, notifies and incremental zone transfers, et cetera. I want to look a little bit closer at our DNSSEC practices, particularly where we're coming from, what we're doing now, and where we'd like to be in the future. Our initial DNSSEC setup was via trust anchors that were published on our website. That was because the parent zones were not yet signed when we initially dove into DNSSEC. Once ARPA, RP6 to ARPA, et cetera, were subsequently signed, we placed DS records at those parents. And a little while after that, we rolled our KSKs to something that no longer points to those trust anchors. When we began, all of our DNSSEC management was done via bind, and we moved to using Secure64 devices to ease operational concerns. Our initial keys were imported to Secure64, which required some massaging because we had a bit of an odd key size, so our vendor wrote some custom code to accommodate that. Our DS record updates were done through a RESTful endpoint that's described in RFC 7745. We had a bash script that would send XML data to that endpoint, and there's a few other steps involved. If you're curious, there's an RFC link there at the bottom. Unfortunately, a lot of those steps were still manual. We had to make some changes to the XML data, like via hand edits, and so that generated a lot of toil, especially when we were doing KSK roles for a fairly significant number of zones. DS record and NS record updates for our forward domains were similarly manual, and that was changed at our registrar, who is JKG. And we used the web front end of ARIN Online to update reverse records at our own registry. All of our interactions with the Secure64 DNS signer, like configuration updates and user management, were manual because the operating system on the device wasn't really a standard Linux OS, so all of our existing config management was not really compatible with it. And the custom code inclusion in the OS created some trepidation around performing OS upgrades, and generally considered the devices to be kind of brittle, especially as most of the staff were mostly unfamiliar with them. Our algorithms, our initial KSKs were algorithm 5, and we published both digest type 1 and digest type 2. Nowadays, we perform all DS and name server record updates via Ansible playbooks. And this automation has brought our key rolls down from weeks or days to hours, plus a bit of a safety time frame that's calculated by each zone's TTL. The playbooks have us eating our own dog food, where we're leveraging the ARIN Online RegRWS API to make corporate reverse updates. And for our corporate forward zones, we make updates against GKG's API. And finally, that IANA RESTful endpoint I mentioned earlier for reverse DNS updates has a playbook that has largely replaced that bash script. To further reduce toil around general system administration tasks like DNS signer work, like configuration updates and user management, we've made some playbooks that handle all of that. We have improved some observability by sending logs via syslog to a central logging setup that's provided some longer-term log storage for us and has exposed the logs to the developers and a few more people who didn't previously have access to the hardware devices. We also wrote a playbook that performed our algorithm change a couple years ago, and we moved from algorithm 5 to algorithm 8. And per RFC 8624, we only publish one digest now, digest type 2. In the future, we'd really like to take humans entirely out of the loop for key rollovers, especially that annual KSK. And we'd like to do some hardware updates soon. We're looking at some network hardware security modules, which might be able to serve multiple purposes within ARIN. And we'd like to move to elliptical curve, likely something like algorithm 13, particularly for the reverse DNS zones. Moving on to DNS application management. We use bind for all of our public-facing DNS. In the past, the configuration updates were made by hand and then backported to version control. The RPMs that installed bind on CentOS were hand-rolled to match the file system layout of our FreeBSD bind installations, which helped us have some sort of operating system heterogeneity amongst our name servers. And the ZoneGen application that I talked about earlier was installed via RPM, and any configuration changes or software upgrades required ceremonious weekend deployments. One last issue we needed to address was unicast DNS instances, which did not provide a lot of site resilience. Today, Bind and ZoneGen are containerized, and configuration management handles all of our deployments, and that can happen faster and during the work week. Our customer record updates are pushed every 4 hours, and we now have a much more geographically distributed set of instances, which are also all anycast at this time. Part of what has improved our reliability is improving the staging and QA environments, and we have a number of test domains we use for testing changes before they actually hit the production zones. And where we see our DNS app management going, we'd like to take those containers, put them into some sort of container orchestration, probably Kubernetes. And we'd like to make our zone changes with the customer updates a little more frequently than they are now. Improve some of our observability, and that's everything.
Thank you.
Any questions? Of course.
It's funny, for .ca, we had the same conclusion: automate everything, no human interaction. So yes, I agree. So we got time for some questions for the previous panels, I guess. Yes. For him, yes.
Hi, it's Peter. You mentioned that you do Git provisioning for some of your zones. I don't think we have to go into details, but it would be nice to know how that works, because we tried that too, and we had lots of race conditions and history cleanup stuff. And so if you have a good solution, and if that would be ideally open source, it would be cool if you could post a link somewhere or say a few words.
Yeah, I don't think we have anything open source for that. The DNS provisioning is definitely something I think we can make some improvements on, but I'm equally interested if anyone else in the room has some.
Okay, but
solutions.
it's a Git repository with zone text files, right?
Exactly.
Okay.
Another question, Carsten.
Thank you. It's Carsten. So my question goes to the previous